we are going on section 1.5. However, if you guys remember, or if you're checking out your class calendar, section 1.4 is due today. We're going on section 1.5. I only have slated for a one-dayer. It's not super long, and a lot of it's going to be kind of review. Favorite online tutor, hopefully you did it. It was due last night.
I did.
If you haven't done it, you can turn it in late for partial. Tonight's homework is homework number 5. Tomorrow is our kind of grace day. What do I mean by that? I mean we have a quiz on Thursday. Tomorrow's Wednesday. I have nothing new unless we need to cover something like we did with the difference quotient today. But other than that, we have nothing new to cover tomorrow. So tomorrow can be kind of our makeup day / review day. Okay? And it's only on sections 1.1 to 1.5. It's half a chapter, but it's half of a long chapter. So look over tonight. You guys had your spiral, all your homeworks all together. Work on homework number 5, but if you have time, go back and look and be like, okay, we've gone over evens in class for the most part. Are there any odds that I just still don't know? And use that as an opportunity to kind of just start thinking about your quiz coming on Thursday. All right? And then tomorrow we'll go over questions on, or the evens on 1.5. We'll go over any big questions you have on any of the homeworks 1 through 5. And then we'll spend some time on reviewing. Sound good? Hey, how crazy is this? Not too bad?
Looks weird.
To get to any individual ordered pair, right? All we got to do is go over a horizontal distance, which is going to be our x, and go up a vertical distance, which is our y. True? Hopefully not too bad. It's still a good point to remember. But the nice thing is we've kind of been practicing this in section 1.1 with thinking to the right a certain amount and up a certain amount. Or if we're going to a different point, to the left a certain amount, up a certain amount. Remembering each coordinate doesn't just stand for how to get there, but how to horizontally and vertically move. We okay-ish? Couple more seconds and okay. Here's something new though. Interval notation is an alternative to inequalities. Did we use inequalities last section? Definitely. For domains, for ranges, especially domains. We use greater thans and less thans and greater than or equal to's. Interval notation says there's a different way, and to some extent, for higher math, a better way. But it's going to mean the exact same thing. As you guys go ahead and write down parentheses, write down brackets, and explain them, let me give you one example below. I'm just going to have you think through it a bit. So go ahead and write. And as you're writing, hopefully you're thinking through what you're writing as well. I know sometimes it's a little hard. But parentheses, limited by but not equal to, whereas a bracket, singular or a pair of brackets, shows limited by and equal to. And with example 1, the very first one, I'm saying they mean the exact same thing. Just the left is more of an elementary notation and the right is a higher math notation. The one on the left is kind of talking about x is in between, is a set of all numbers in between. And on the right, it's saying x can be an element of, or x can be any value between, in the interval, -2 to 5, not including -2, but including 5. Remember the little e is within, is an element of, is a part of the set of all, or the interval of all numbers. The comma is kind of symbolizing from -2 to 5. Comma kind of means 2. or through. So the sandwich, you're going to have both numbers of the sandwich inequality. You just have to look at the inequality and say, can it equal? No. So what did I put? Parenthesis. Can it equal? Yes. So what did I put? Bracket. Okay. What if they were both or equal to? What would the key be? If it was or equal to? 2 brackets. If it was not or equal to? 2 parentheses. Now, think about this one. Okay. How low can x go?
3.
3. So x is within 3 bracket because it's or equal to. Here's the tricky part though. How high can it go?
Infinity. Did you put a bracket or parentheses?
Can you get to infinity?
No.
Yeah. You can only get closer
But
and
you can't
closer.
do all of them.
It can be all of them, but can I close infinity?
No.
Exactly. I can stop at infinity, but infinity keeps on going. I can never equal infinity. I can just go that direction. Infinity is not a number, it's more of an idea. So 3 is the beginning, like on a number line. 3 would be the beginning. And how long would that right arrow go? Forever. So I just mark the end as positive infinity. Now, you guys try the bottom one. X less than 1. And just a hint, 1 should not be the first number you write or the first thing you write. 1's not how far left, 1 is how far right. Distracting.
You say yeah.
Get through. 1 should not be the first thing you write, it should be the last. Besides notation. As you guys are doing that, let me do the number line representation for the first. Just to remind you, open circles versus closed circles. So an open circle is like a parenthesis, a closed circle is like a bracket. What do you guys think? How far left can x go? Nice. And how far right? With a? Because? So think parenthesis kind of open-ended. Bracket closed, right? Kind of. Parenthesis still marks a boundary, but it's more open-ended, whereas a bracket is closed. Hopefully that helps a little bit. Questions on interval notation? What's the comma mean?
2.
To or through. What do I put first? The answer to the question, how far?
Left.
And on the right, how far? So this one would be open, how far left? Negative. Cool? That didn't work. There we go. Wait a minute. Didn't we already do this? It's like review. Yep. But how are we going to be writing domains and ranges? Try to use interval notation. You can still use inequalities or think inequalities, but now you're going to be thinking interval notation for, and we kind of were starting it, weren't we? I was kind of using the little like E before. Maybe I should have. But we're going to be thinking about interval notation. But if we're asking ourselves the question, how far left, how far right, how far down, how far up, what am I looking at? What am I looking at? A graph. But the same way that we talked about domain is all the x's, range is all the y's, all the possible x's, all the possible y's. Let's just say you're going to see more graphs this section. You're going to have to probably, in visually looking at a graph, asking yourself visual questions like, how far left, how far right, how far down, how far up. Why am I going to change the wording? And if you're in your notes, I want you to change it to, why am I going to say down? to up instead of up to down. I'm going from negative to positive, smaller to bigger, kind of. Interval notation, what would be on the left, what would be on the right? Because interval notation, remember, what's on the left is how low it goes, which would be down. What's on the right is how high it goes, which would be up. But the nice thing is the idea is a review, just you're going to have more graphs. You're going to have more graphs. And feel free, guys, if you want to, just because sometimes I go fast and there really wasn't much to say on this page. Remember, like for left and right, you can definitely be using like arrows just to help yourselves out. It doesn't have to be full words, et cetera, et cetera. Okay? Keep going. Now, pencils down. If you want to copy this in your notes tonight, totally fine. I don't mind. But for right now, let's take a time. Let's just think through. Let's just think through, okay? Funny graph. Ugh, what's going on? But domain. Just ask yourself the question. Hold on. First, let's set it up. How far left? -1. Don't worry. Just ask yourself the question, how far left? Map it. -1. Including or not including?
Including.
Because it's filled in. Perfect. How far right? 5. Not including. Could you use a little like greater than or equal to, less than? Yes. But interval notation we're practicing. What's f of -1? F times -1? I don't understand. The y value at -1. 1. Right? F of -1. Function notation. It's just asking for the y value. So you guys, f of 2. -3. Go find when x is, remember f of x is 2, y is -3. Range. Y is within. How low does it go?
-3.
How high does it go?
3.
So -3 sure looks like including to me. 3 looks like including to me as well. Yeah? Okay. That's what I mean by you're going to be seeing graphs. Zeros. Huh? Zeros. They're just like x-intercepts. Have we done this? Yeah. But instead of thinking y to 0, just think f of x to 0 or equals 0. And how do we solve? Am I going to write? Solve by factoring as much as possible, right? Because if you start moving stuff, you're going to lose answers, and then just all hope is lost. Or at least all hope is lost of getting every single answer. Factor, factor, factor. Factor, factor, factor. See where we're at. Quick factor example. Struggle. The rest isn't hard, it just takes a little bit of time to look at. Guys, long story short, we're not going to finish all the ideas. Let me just show you one more for today. Homework, try to get as much done as you can for tomorrow. We'll probably just finish section 5 tomorrow. But to be honest, we're still going to fit in a review tomorrow. Because we can do it. And it's a whole lot better to have one tomorrow, have a quiz on Thursday than Tuesday after Labor Day weekend and Spirit Day. That would just be a mess. Recipe for disaster. So we can do it. We're going to finish section 5 tomorrow. And finish section 5 tomorrow and review. Okay? The nice thing is this section is great. It has you review all sorts of stuff. Just with new notation. Does this page kind of make sense? As to which branches are labeled which? Just think, reading on a page in English. You move from left to right. What are the y's doing? Falling. Oh, decreasing. The function's decreasing. Constant increasing. So how would I state it? I could state the function is decreasing. X is within. From -2, we always use the x values, to 0. That whole time, we're just going to keep it open for all of these. We can say constant x is within 0 to 2. We use the x values to describe. And we're going to say increasing, can you guys tell? 2 to 4. Just showing you other uses for interval notation. All right, we're going to have to finish. I'm going to save the entire section online. If you guys want to look, there's a formula we didn't get to write down. And even an odd we didn't get to review with symmetries. But we'll see you tomorrow. We'll see you. Priya, do you have a question?
Yeah, why did you brackets?
Long story